The multiplication division relationship describes the space between different points in time, or the space between different locations. And if you understand that a division, if you understand what the multiplication division relationship is ultimately, then you could try to understand what it is to count negations. When we are able to count anything that is a manifestation of one, we're able to count 4 tables as they exist physically, but you're not able to start at -1. You're only able to understand that you can take away 4 tables and understand the negative value in that sense of anything that you count. But maybe you could understand what negations are counted in if you understand the multiplication division relationship, and more specifically, what is a denominator counted in? When a numerator is ultimately counted additively, or changes in numerators are counted additively when they have the same denominator, or are basically in the same mode. But if you can understand the order of the modes or of the denominators, which you don't readily understand how you jump from 2 as a denominator to 3 as a denominator to 4 as a denominator, because in order to make those jumps, you need these conversions through multiplication and division. And ultimately, if you could understand what divisions are counted in, you're understanding what the relationship is between 1 and 2 as a denominator, and then 2 and 3 as a denominator. If you can find the ultimate unit that goes 1, 2, 3, like to perform the order, to understand and comprehend the ordering of denominators 1, 2, 3, 4, 5, 6, 7 the same way you would in an additive sense or a counting sense, if you can get to the point where you understand that language of denomination, the language, the order of the language of denominator, or you're able to translate addition into divisibilities, the denominators, or divisors, the way that if you're able to understand that language, the way that divisions are ordered, then you can possibly understand what counts, how a negation is counted. But more importantly, if you understand how divisions are ordered, that's going to tell you, that would be the next step in understanding undefinability, or the element that is most relative, or understanding time ultimately, or understanding the pattern of prime numbers, because the pattern of prime numbers is at the heart of understanding the rules of numbers as they exist multiplicatively, or the way that each number is relative to every single other number. We'll tell you prime numbers because it's all the prime numbers that are the ones that are most efficiently relative to all other numbers, and therefore would most efficiently be able to build a space 0 to 1 without all the replicatory composite numbers. But it's prime numbers that designate mixtures and are the efficient factors or components of spectrums. And if you understand the heart of like what a multiplication is counted in, what a product is counted in, and what a division is counted in, then you will have ordered numbers multiplicatively, which would be pretty much the same as ordering them, understanding the way that prime numbers are ordered additively. But it's kind of like a translation of language, and pretty much the translation of language is between addition, subtraction, and multiplication, division, and it's the same thing as the translation between finite and infinite, or the translation between microscopic and macroscopic. And it is like that the middle part is ultimately relativity, but I guess I don't know. And further explanation, but so if you wanted to find out the prime numbers, I suggest your next step, what you got to do is you have to figure out how divisions are numbered. You have to understand the order of divisibilities, or of all denominators. If you understand how denominators are ordered the same way additions or things that are counted are ordered, then you will have found some sort of link between entire operations. And that link is because relativity at the middle of the spectrum is one thing as two things at the middle of the spectrum. And that's what relativity is, because it relates two things. Any manifestation of relativity relates two things to each other. And the only manifestation of relativity that relates subjectivity to objectivity is the very middle one. But any space element within the spectrum is a relating element and relates at least two things. And so relativity at its most base level is one thing as two things, whereas the bookends of the spectrum are two things as one thing, or two things at different points in time, whereas relativity is an integration of two things at one time or at one location, because it is a one as two as opposed to a two as one. It's a one as two is what relativity as defined is, because it has to relate two things. So in order to find the middle of what's finite and what's infinite, then you have to figure out what it means for one thing to be two things, and which is kind of like seeing one thing at two different levels versus two things at one level, or seeing the translation of one word into two languages versus two words in one language, or seeing time as opposed to space, where time itself is an integration of the past and the future, and where one of them would be technically positive and then one of them would be negative, but it shows two in a superposition of two things as relative to each other. That's what a manifestation of time is, as opposed to something that's finite or ultimately infinite. But I guess I'm sort of saying that, like, subjectivity is like presents you negative manifestations, and objectivity does present positive manifestations if you're viewing all of them entirely as a spectrum. So if you want to figure out the prime numbers, you should figure out how to count within an infinite space, meaning you should be able to figure out where be able to count where divisions are able to be created, and divisions are created within spaces and exist within a space 0 to 1, as opposed to external to a 1, or it's something that can be counted quantifiably. So if you want to find out the middle, and like I'm saying that it could lead you to the prime numbers pretty much. If you want to find out what the prime numbers are, the next step is you have to count divisions. So if you can count division and the operation of that and understand what that operation is counted in,